Hello class! Welcome to our very first lecture of statistics. And in this week's lecture, we're going to cover all of chapter 1 and just the beginning of chapter 6. So let's talk about our objectives for this week's lectures. And you'll notice that there are 3 videos to win lecture. And in this first video, we're going to cover our first objective, which is to know why it's important to understand and study statistics. So why are you even taking this class? Why is it considered a core requirement for the health science major and minors, as well as a GE for all the other students that have different majors? Part 2 is going to cover our objective of understanding how different types of statistics can be used to describe a health topic, make inferences about a population from a sample, test the theory with hypotheses, so this is also known as hypothesis testing, and make predictions. And of these 4 things that we can do with statistics, we're going to learn about 3 of these. We're going to learn how we describe a health topic, how we make inferences, and how we test hypotheses. One thing we're not going to learn, though, is how we make predictions. Although your textbook does cover this, which is also known as regression, we're not going to learn that in this semester. And then the last part, part 3, is going to cover our third objective, which is understanding the different characteristics that variables can have. And this is really going to talk a little bit about the stuff that you're going to read in chapter 6. Now, if you think about this, if I'm bringing in a material that's not covered until chapter 6 of the textbook, but we're talking about it the very first day of the semester, that probably should tell you something in terms of the importance and the weight of these concepts and making sure that you understand them, because it's really going to set up the foundation for everything else that we're going to learn from week 2 till the very end of the semester. So making sure you understand part 3, our third objective for week 1, is crucial for you to make sure that you master this concept so you can do well for the rest of the semester. And so you'll see here that this week's material is all conceptual, that there are no mathematical calculations. Now, anecdotally and historically, a lot of my students have found that the calculations that we're going to do in this class, while it's considered a math class, is actually fairly simple, fairly basic. So you're not going to have to do super crazy calculus, but really basic algebra. And so the calculator that you need is really only going to need to do computations such as square roots, nothing else than that. However, because the calculations are relatively simple, a lot of students focus a lot of the time on the calculations because a lot of students struggle with math. And so they don't dedicate the energy and the time of understanding and mastering the conceptual stuff that we're learning, which I think is really that much more important than just the calculations themselves. And so what you'll learn as we progress through this semester is that you want to make sure you understand the calculations. When do we use them? Why do we use them? What do they mean? But really, the basis of the calculations is all based on the conceptual stuff. When do we use these? Why do we use them? How do we interpret them? So don't slack in terms of studying the conceptual stuff because it's just words. Because you're going to do yourself a disservice if you just focus on the math and not the conceptual. So with that, let's move on to our first objective of why it's important to understand and study statistics. So here we have a bar graph. Go ahead and pause the video, spend a few moments, and come up with 2 different statements. 2 statements that you can interpret or come to a conclusion based upon just looking at this visual. When you think you've come up with 2 statements, 2 conclusions, 2 interpretations, go ahead and unpause the video to hear what I have to say. Alright, so hopefully you gave yourself an opportunity to actually sit and look at these graphs here and come up with some interpretation. So first of all, let's take a look at what it is that we're even looking at. Well, we have 2 bar graphs. We see the top bar graph is essentially telling us the number of gonorrhea cases that were reported, and our second bar graph is telling us how many chlamydia cases were reported. And we see that these different color schemes in each of these bar graphs indicates a specific age group. So we see that a light blue covers those who are ages 0 to 14 years old, the red were 15 to 19-year-olds, the purple 20 to 24, and so on and so forth with the different various shades of green. And we see what these numbers are is from the source. We see this is coming from the CDC. This is published in 2014, and the title of this is Reported STDs in the U.S. 2012 National Data on Chlamydia, Gonorrhea, and Syphilis. And so we can see that in 2012, there were 334,826 cases of gonorrhea. And in that same year, we see that there were 1,422,976 chlamydia cases. So just right off the bat there, you can see that there were more chlamydia cases reported than there were gonorrhea cases. That may have been something that you wrote down. Well, if we look at each of these bar graphs individually, let's just look at the top one, just gonorrhea cases. Which age group made up the majority of these cases? Well, hopefully you said those that made up the purple bracket, right? We see that purple made up 34% of the 300 plus thousand cases, and that 34% of those cases fell among the 20 to 24-year-olds. And we see that the second most cases reported for gonorrhea were among those between 15 and 19. So we can say that the majority, right, we can see that 58% of the 300 plus thousand cases of gonorrhea occurred in younger adults, 15 to 24-year-olds. Most likely your age group, your peers. Hey, you might even be one of those cases. And so given that, that kind of gives us an idea of who's being affected most by this particular STD. Let's look at chlamydia. We know that there was actually more than 3 times the cases of chlamydia than there were gonorrhea cases in 2012. That may have been another thing that you may have written down. But let me ask the same question. Among whom did these 1.4 million cases occur in? What age group? See, the majority of them, again, 20 to 24-year-olds. And really, almost 70% of these 1.4 million cases of chlamydia occurred in that same age group, those young adults, 15 to 24-year-olds. And so thinking about this, if you were a health researcher, or maybe worked at the health department, or somebody who was trying to develop a health promotion program, knowing this information here, knowing these statistics, would you want to spend your time, your energy, and your resources, specifically money, on trying to advertise and reach out to, let's say, older adults or younger adults and trying to prevent the spread of STDs, knowing this data here? Most likely you'll want to target the young adults, right? Because we see that the young adults are the one that are actually getting these STDs compared to older adults. Look at that, 40-year-olds and above. Less than 10% of gonorrhea cases and less than 5% of chlamydia cases. So why would you want to dedicate all your time and energy and resources to reaching out to older adults if they only make up less than 10% of the cases reported in a given year? You want to focus in on the people that it's really affecting. Well, we see here the majority of them are young adults. So hopefully this gives you a little bit of understanding of why it's important for us to collect data, report statistics, and report it in some meaningful way that we can actually interpret that and do something with it. Right? What if I just put down a list of 2 million people and said, did you have gonorrhea? Did you have chlamydia? Yes or no? Would you be able to come up with that type of information or that type of conclusion that quickly if I gave you all of that raw data? Most likely not, right? It'd probably take you days, months to actually work through that raw data and come up with something like this. But yet, in a matter of a couple minutes, you were able to come to some conclusion and do something with it. So hopefully this is giving you an idea of how powerful statistics can be in everyday life. Here's another figure. As the title says, the percent distribution of 5 leading causes of death by age group. And this is in 2011 preliminary data. We see this is coming from the source, the National Vital Statistics System, mortality. So this is all number of deaths. So go ahead, just like our previous slide, pause the video and soak in these 4 different pie graphs and see if you can come up with 2 conclusions, 2 interpretations. When you come up with those conclusions or interpretations, go ahead and unpause the video to hear what I have to say. All right, so hopefully you gave yourself the chance to look over these pie graphs and come up with some story or some conclusion. So let's start with the first pie graph, ages 1 through 24. What conclusion can you draw from looking at just this one pie graph? Well, we see that the majority of deaths for people ages 1 through 24 were due to accidents. Right? We see the smallest were due to heart disease and cancer. So we know heart disease and cancer are, what, are they acute or chronic conditions? They're chronic conditions, things that develop over a long period of time. Compared to accidents, well, those happen at any given time without any notice. So these are more acute conditions. So people are dying more of acute conditions compared to chronic conditions. And most of them are dying from accidents, and then the 2 following that would be homicide, suicide, and then also obviously all other causes. But let's take a look at those ages 25 to 44. What are the majority of them dying from? All other causes. Okay, so not necessarily accidents or heart disease or cancer, but next to that, accidents as well, right? We see the second leading cause of death are due to accidents. Second would be due to all other causes. Same thing for those ages 1 through 24. So just looking at people ages 1 through 44 years old, we can see that the top 2 leading causes of death are accidents and some other cause that isn't homicide, suicide, cancer, or heart disease. But now let's take a look at the bottom 2 pie graphs. Those ages 45 to 64 and those 65 years and older. So looking at those ages 45 to 64, what's the leading cause of death for these folks? It's a tie between cancer and all other causes. Well, look at that. All other causes is something that we saw for ages 1 through 24 and those ages 25 to 44. But cancer is tied with the number 1, which is a chronic condition. Look at accidents. Only 7% of deaths, of those 505,000 deaths, were among people who had some type of accident, compared to the 38% of the nearly 40,000 people who were ages 1 through 24 years old and how they died. Big difference. And then what about our oldest group, ages 65 and older? And we had the leading number of deaths here. We had 1.8 million number of deaths. So among those 65 and older, what are the leading causes of death? All other causes and heart disease. And behind that, cancer. So now we're seeing kind of a shift from the top 2 pie graphs, those who are 44 years and younger, dying mostly from accidents and some other cause, compared to those who are 45 years and older, they're dying from the same thing, all other causes, but mostly from chronic conditions, cancer, heart disease. So again, thinking about this, you can do all sorts of things, from developing health promotion programs, to educating the young folks on trying to reduce accidents, because most of those things are accidents, so that means most likely preventable, and try to target those who are older and trying to make sure that they have a good quality of life, making sure that they don't go into any further morbidity that they maybe don't necessarily die at such a young age, and that they don't actually develop these chronic conditions, to even policy. So there's all sorts of things that we can do with these statistics. And so of some of the stuff that we talked about or that I mentioned, hopefully these are some statements that you may have written down for your interpretations. So hopefully you're starting to see how statistics are really used to inform us, educate us about what's happening around us, the world around us. But also, it also influences us. It influences us to make certain decisions, for us to ration our resources, to allocate energy and money towards a certain cause or towards a certain population, because we know what's going on. And with all the information that we're seeing around us, it's just some way of us to really consolidate it, summarize it, be able to make sense of it. And so if you think about these images down here at the bottom, a lot of these had to do with medications, pharmaceutical drugs. And if you're familiar with the pharmaceutical drug industry, you know that in order for a drug to make it out into the market so that the masses can utilize it, it has to go through a rigorous clinical trial process. And that rigorous clinical trial process is really the collection of data, high quality data that's collected from people who are trained in collecting this data, and then collecting this data and analyzing it, making sense of it all by using statistics. And that's what we're going to do in this class, is really be able to take some data, whether it's given to us already and we just crunch the numbers, or we collect it ourselves and we crunch the numbers, but how do we use the data to actually make sense of the world around us and do something to better the world? This is what the purpose of statistics is. How can we collect this information and in turn help us understand the world around us and improve the world around us? And so with that concludes part 1 of week 1 lecture. Move on to part 2 to learn a little bit more about statistics and different characteristics that these statistics have.